Hi, I'm Cindy Nguyen, and this is my Intro to Arcsine video. To make solving for Arcsine an easier process, I thought it would be best to help you guys memorize the units on the unit circle. Let's start off with the reference angle of pi over 6. These angles are made up of 30 degrees with rad 3 over 2 as the cosine x and 1/2 as the sine y. As you can see, all reference angles of pi over 6 have rad 3 over 2 as the x-coordinate and 1/2 as the y-coordinate. What determines the positive or negative sign in the front is which quadrant the points lie in. 30 degrees, that sounds familiar, right? Because the unit circle is made out of special right triangles with the angles of 45, 45, 90 and 30, 60, 90, which can be seen on the right side. 30, 60, 90 triangles are made up of with the lengths of rad 3a, 2a, and a. To convert this triangle to fit the triangle of the unit circle, we would have to get the hypotenuse to 1. To do that, we would divide all the sides by 2, which gets us to 1 as the hypotenuse, 1/2 as a side, and the other side length would be rad 3 over 2. A similar pattern can be seen for the angles with a reference angle of pi over 3. As you can see, it has the same numbers as the reference angles of pi over 6. However, 1/2 is now the x-coordinate cosine, and rad 3 over 2 is now the y-coordinate. So let's keep those two numbers in mind, 1/2 and rad 3 over 2, which we got from the 30, 60, 90 triangle. Let's move on to 45, 45, 90 special right triangle. It is basically the same thing where rad 2 times k is the hypotenuse, and then k is the length of the two other sides. In order to get 1 as the hypotenuse, we would divide rad 2 times k by rad 2 to get it to 1, and then we would also divide the other sides by radical 2, which gives us rad 2 over 2. You only need to remember three numbers: 1/2, rad 3 over 2, and rad 2 over 2. So I'm going to give you guys a brief summary. Reference angles with pi over 6 always have rad 3 over 2 as the x-coordinate and 1/2 as the y-coordinate. But you have to remember that the positive or negative sign could change depending on which quadrant it lies in. And the same thing for reference angles with pi over 3. However, 1/2 is now in the front and rad 3 is now in the back. Don't forget the positive negative signs. And the third number that you have to remember is rad 2 over 2. It is the x-coordinate and the y-coordinate. The positive and negative sign, again, only changes depending on which quadrant it lies in. Another thing you would want to know is coterminal angle. A coterminal of an angle in standard position is an angle whose terminal side lands perfectly on theta's terminal side. So basically what it's trying to tell you is that it would make another loop around the original terminal angle to make a coterminal angle. And to make an entire loop or circle, that would be equivalent to 2 pi or 360 degrees. So to solve a coterminal angle, you would need to add by 2 pi or subtract by 2 pi. Or in degrees, you can add it by 360 degrees or subtract it by 360 degrees as many times as you'd like. So I made an example for you guys. So pi over 3. I added it by 6 pi over 3, which is equivalent to 2 pi giving me 7 pi over 3. Or you could also subtract it by 2 pi, which is the equation below. Yeah. So pi over 3 subtracted by 6 pi over 3 equals negative 5 pi over 3. 7 pi over 3 and negative 5 pi over 3 are coterminal angles of pi over 3. So I did it in degrees as well. 45 degrees is the original angle. So when you add it by 360 degrees, that would give you 405 degrees, and when you subtract 45 by 360 degrees, that would give you negative 315 degrees. So 405 degrees and negative 315 degrees are coterminal angles of 45 degrees. Okay, so let's actually move on to arcsine now. What exactly is arcsine? So the word arcsine can also be referred to as the inverse sine, and I typed out what it could look like below. Yeah. So to put it into simpler terms, let's look at it like this. Sine of 45 degrees equals radical 2 over 2, which is a point on the graph. So what arcsine is asking is basically the opposite of that. So what angle of arcsine would give us the point rad 2 over 2? Here, it looks like this. So arcsine of rad 2 over 2, which is the point, would give us the angle of 45 degrees, or in radians, that would be pi over 4. So arcsine is restricted from negative pi over 2 to pi over 2 in order to pass the horizontal line test, where the curve only touches the line once. As you can see in the original graph, the curve touches the horizontal line multiple times, so it does not pass the horizontal line test. However, if you restrict it to the blue box, which is now written in the graph next to it, it passes the horizontal line test. That is for sine, but to get arcsine, you would need to get the reflection of this curve across y equals x. So the range would become restricted to negative pi over 2 to pi over 2. So the graph of arcsine would basically look like this. What makes this graph different than the sine graph is that now the range is restricted to negative pi over 2 to pi over 2. Range is the y coordinates, okay guys? Alright, now let's move on to example problems. Find the value of arcsine negative 1/2. Write your answers in radians in terms of pi, and I'm also asking you guys to write your answers in degrees. So note that your answers must be in between negative pi to pi over 2. This means that our point must, or our degree or angle, must be in quadrants 4 to 1. And don't forget the sine is also equal to the y coordinate. So first let's ask ourselves, sine of what angle equals to the point negative 1/2? So we remember that sine is the y coordinate, and negative 1/2 is part of the reference angles of pi over 6. So being that y is negative, that would mean that the answer would either be in quadrants 3 or 4. 7 pi over 6 is a possible answer because it gives us the y coordinate of negative 1/2. However, it is not in the highlighted blue area, so we can cross it out. And now, another possible answer is 11 pi over 6. It is in the blue area, and it equals, or it gives us the point where sine is negative 1/2. However, it is not between negative pi over 2 to pi over 2. As you can see, 11 pi over 6 is a lot more than negative pi over 2 to pi over 2. So what can we do? Going back to coterminal angles, we would need to divide it and then subtract it by 2 pi, like this, giving us negative pi over 6. Negative pi over 6 is the answer because it fits in between negative pi over 2 to pi over 2. And it also gives us the point of negative 1/2. So we found the answers in radians in terms of pi, and now let's find it in degrees. Negative pi over 6 equals negative 30 degrees. The initial side starts right here, and going down, that would be, well, we're going clockwise. And when we go clockwise, that would give us a negative angle. Okay, now on to example problem number 2. Find the value of arcsine rad3 over 2. Write your answer in radians in terms of pi and degrees. So note that your answers must be in between negative pi over 2 to pi over 2, which I already highlighted for you guys. And sine is equal to the y-coordinate. So let's ask ourselves, sine of what angle gives us rad3 over 2 as a point? Sine being rad3 over 2 as a point would mean that the reference angle is pi over 3. So I started off with a possible answer, 2 pi over 3. However, I crossed it out because 2 pi over 3 does not meet the criteria of being in between negative pi over 2 to pi over 2. Another possible answer is rad3 over 2 because it also gives us the y-coordinate of positive rad3 over 2. This is in the blue area and it meets the requirements of being in between negative pi over 2 to pi over 2. So it is our answer. So to convert it into degrees, that would mean that pi over 3 equals 60 degrees.